Okay, so we're back. This is the second part of the sixth video, going through and looking at physical limits for hazards for HACCP. Physical critical control points, an example of control limits. Easy one, metal detection. If we're going through and we're looking at a metal detector, we want to go through and have a rejection of 330 seconds. That's a measurement in inches. Series 400 stainless steel sphere 100% of the time. We can go through and we can use that as far as calibration. We want to go through and find that there are no metal, there's no hazardous metal, ferrous and non-ferrous, detectable. That's one of the neat things about some of the stuff that if you go into the plants nowadays, and you know, some of you students have participated in field trips, they make pins like what would have been an all plastic pin. Now it has metal in it, so that if it is ground to pieces inside of a food product, you will be able to go through and detect the metal that was in the pin. You may go through and put a magnet in there so that you would have no hazardous metal. Screen, you could go through and you could have that depending upon the product, so that if we're making a slurry, like a hot dog, we could go through and we could see that a screen would be present to go through and see if there was any larger pieces, and that would go through and catch. But the thing is, you got to go through and make sure that your screen is in good repair. If you have a sifter, you can go through and look at the tailings, and those are the bad, not the bad, those are the end parts of what you have ground. That's a, you can also go through and hear that. That is a term used in mining, that they will have tailings. That is what you're actually going through, and like I say, grinding up, that's the end point that you're looking at. Principle 3. Establish the critical limits which must be met at each identified critical control point. Critical limit is defined as the maximum or minimum value to which a physical, biological, or chemical hazard must be controlled at a CCP to prevent, eliminate, or reduce to an acceptable level the occurrence of the identified food safety hazard. As a CCP may have more than one critical limit, if any of those limits, such as temperature, humidity, time, pH, water activity, is exceeded, the CCP is out of control, and you're not in compliance, and you'll have to report that. It's not a fun thing to do. If we're looking at a meat patty as an example, just basically what you would recognize as far as a hamburger patty, minimum operating temperature of cooker and time to achieve lethality at the center of the patty. Now you would want to go through and measure at the center, because the center should be the coldest part of it, should be the one that's going to go through and have the most abuse ability, because on the outside you know that, hey, it's going to be cooked to a higher extent on the outside, on the edges, just because of how heat is going to go through and be transferred from an outer edge to an inner edge. You would need to go through and consider patty thickness. How thick is the patty itself? Oven humidity. If we're going through and we're looking at how much moisture is in the oven. Patty composition. Is there a lot of fat present? You know, those things would go through and determine how you would need to go through and treat your patty as far as those critical limits for temperature. Things that should be considered. Regulatory requirements to which the process must meet, and that's USDA, FDA regulatory requirements. The time and temperature that's used in making the product. That's when we go back and we look as far as the D value, the Z values. The critical limits must be drawn from specific challenge studies or from recognized experts. Now, a challenge study is one to where you go through and you have a sample and you actually put microbial inoculation loops, or you go through and you subject it to broth. You have contaminated it. You have contaminated it because you want to go through and see, hey, if I have this meat patty and I apply 10 to the 6th CFUs, or you put 1 times 10 to the exponent of 6 colony forming units onto that patty, you've done that. You go through and you cook it, or you heat treat it. Now it's one of those to go through and take that, to put it in a stomacher, put it in a bag, put some broth in there, to go through and see, hey, how many bacteria, how many colony forming units would you now get out? Would you have a 1 log reduction? And if so, then you can go through and say, hey, we've met a 1 log reduction. But realistically, at a 10 to the 6th, you've brought it down to a 10 to the 5th. Is it safe at 10 to the 5th? That's where we got to go through and we got to kind of wonder a little bit. To each preventive measure that's intended to apply to CCPs, we need to establish those critical limits. So you got to go through and figure those out. Critical limit is one or more prescribed tolerance that must be met to ensure that a critical control point effectively controls that microbiological, chemical, or physical hazards. Critical limits on these critical control points represents the boundaries for safety. You cross the line, you're no longer safe. So what is your critical limit? How high of a temperature, how low of a temperature, how high of a salt level, how low of a water activity? Those are your critical limits. Those are the things that you're trying to go through and figure out. They're criteria or point at which there is a line between acceptable and unacceptable, safe, unsafe, alive, or dead. You may want to go through and look as far as legal standpoint. What's the minimum we can get by? Because that's how a lot of times business does things. You may go through and look at as far as safety. Hey, we always want to make sure that we have the safest food product. You may want to do above and beyond what is legally required to go through and make an assured safe product, right? Something that nobody's kid, nobody's husband or wife is going to go through and get sick and die from eating your food product. Now, legally, you may be able to go through and get away with what you've done, but you won't always be safe. Measurement criteria, visible and measurable. You need to be able to go through and make sure that, hey, we can figure this out and we can prove that we've done what we needed to do. Critical limits. Are they attainable? Can you actually go through and do them? Are they arbitrary? Did you go through and come up with 35 degrees Fahrenheit? Did you come up with 137 as far as temperature for cooking? Where did you get that number from? 3/16 as far as a size for metal. Where did you get that? So is it arbitrary, or did you go through and use science? Hey, we're going to go through and make sure that this is cooled below 40 degrees Fahrenheit. Okay. That's not arbitrary. That's refrigeration. Are they legal? Did you meet the legal requirements as far as how fast your carcass must cool down after you've slaughtered the animal? There is a legal requirement there. Will the limit control the hazard? Is it enough? And that's what I say. You may be legal, but it still may not be safe. So, what's your ruling there? And then how and why did you set that limit? It goes back a little bit to that arbitrary. How did you come up with this one? Is it reasonable? Cattle slaughter established, as far as zero tolerance. CCP identifies visible fecal, ingesta, and milk contamination is not sufficient to control microscopic pathogens, E. coli 0157H7. You can't just look at it. You actually have to go through and swab and test. So you need to go through and have indication of control of sanitary dressing procedures during slaughter. And that comes out of 62 as far as the title. FR is the Federal Register 63254. And you can see actually it goes through and it shows you the link from the Government Printing Office, the GPO. So it's one of those, hey, you can click on that and it'll actually take you to it. Questions that are to be answered in determining the critical limit for each CCP. What are the critical components associated with that CCP? Is it temperature? Is it time? Is it cooking? Is it heat? Is it retort? Is it a chemical? Is it a toxin? Is it metal? What are the critical components? And then at what level or what point would each of these critical components become a safety hazard? Is the metal the size of a penny? Obviously somebody's going to go through and choke and possibly die if they were to go through and swallow a penny. So it's one of those of, hey, we can't have metal that large. Is the metal round or is it sharp? That's where it's going to get a little dicey. Which bacteria is present? Is it just generic E. coli or is it E. coli 157H7? Those are things where you got to go through and you got to identify what is critical. Criteria most frequently utilized critical limits: time, temperature. You'll continue to hear it. Humidity when you're cooking, moisture level as far as water activity, pH, titratable acidity. That is different than pH. Titratable acidity is going through and measuring what is the acidity of the food product for which it's able to go through and carry out a reduction of growth. Are there any preservatives? What's the salt concentration? What's the available chlorine? Chlorine can act as a strong oxidizer. So what ppm, parts per million, ppm, parts per million, or ppb, yes, obviously parts per billion, did you go through and use as far as chlorine? And how much is available to actually go through and oxidize or destroy microorganisms? And then maybe viscosity. Viscosity can work because of that's going to go hand in hand as far as moisture level, humidity, to go through and like to let you understand or help you understand what is the flowability, right? Sources of information on critical limits, places you can go through and get information, surveys, literature searches, supplier records, data, regulatory guidelines of USDA, FDA, experimental studies. You may go through and do one of those challenge studies. Experts, you can ask people. You get people that's willing to go to court for you to go through and say, yes, hey, if you did this, then it should be safe. Boom, an expert. You could be that expert even. Critical limits, HACCP plan. Critical limits are the boundaries for that safety. They need to be exact and specific. You cannot put a range on a temperature. You need to identify an exact temperature. HACCP plan should not include ranges as critical limits. Establishment of critical limits for the identified CCP are either through regulatory requirements or through the technical scientific literature, which are the basis of the production process. Two types as far as critical limits. You can go through and you can have an upper critical limit or a UCL, or you can go through and have a lower critical limit, an LCL. Upper critical limit is where the set amount or level cannot be exceeded. To address the hazard in a ground product of metal fragments from your grinding equipment, the upper critical limit from the preventative measure is 0. So at that point, you can have 0 metal fragments. Lower critical limit, where a minimum amount is required to produce a safe effect. The addition of an acidifier or something to go through and decrease the pH or to make it more acidic to inhibit bacterial growth. What is the minimum amount needed to go through and decrease bacterial growth? Example of critical limits, cooking. Is it a CCP? Yes. Why? Because there's nothing else that's going to go through and make that product safe after you cook it. You need to go through and fully cook it. So at that point, you go through and you have oven temperature. What's your oven temperature? Fahrenheit, to go through and make sure it's safe. Time, rate of heating, cooling, belt speed. If you're cooking it on a belt, on a conveyor belt that's going through an oven, you might go through and allow it to sit in there so many feet per minute as far as your belt speed. If it goes through too fast, then again, it's the time that did not allow the oven to reach the temperature for the food product. Patty thickness makes a difference. Like I say, the thicker the patty, the longer it needs to stay in there to reach that higher temperature. Patty composition, is it all beef? Is it chicken? And that's part of, like I say, as far as the fat content. Oven humidity, what's the relative humidity? Because that will change how fast or how easy it is for you to go through and increase the temperature. An example, like I say, as far as that HACCP plan, if we're looking at the lamb carcass, CCP1 final carcass inspection, going through and looking at bacterial growth, right? So, I mean, there's different things you can go through and you can identify. Operational limits. Criteria that are more stringent than critical limits and that are used by an operator to reduce the risk of deviation. You may notice that you are getting near being out of compliant before you're actually out of compliant. So the critical limit would go through and say, hey, you're out of compliant, it's an unsafe product. Your operational limit goes through and says, hey, wait a minute, we're not out of compliance yet, but we notice that we're getting close. The temperature on this cooler continues to increase every hour. The belt speed continues to increase, so at that point, the temperature of our hamburgers decreases every hour. Hey, we're operating at these parameters. We're not out of compliance yet, but we see that we may get there. So it's one of those, you may go through and do it for quality. You may do it so that you don't exceed critical limits to account for normal variability. Next video.